Okay, so we're now going to start going over conditional probability, and that's essentially finding the probability of something occurring, knowing that something else has occurred. In real life, as you probably can understand, like when you're trying to figure out, the odds of something occurring, the more information you have, the more, precise, the more accurate your prediction can be. So like, say like, for example, you're like, what are the chances of someone, having an Instagram account? Say it's like maybe 40% or something. What if I say, well, what are the chances of someone having an Instagram account given that they're 2 years old? It's probably zero. You probably know that babies don't, have Instagram accounts, they can't barely talk. So that's a conditional probability. You knowing that their baby is gonna, affect the chances of them having an Instagram account, and vice versa. What's the probability of someone having an Instagram account given that they're 17 or 18 years old? It's probably going to be higher than your normal guess. So we call that a conditional probability. So we denote this like this. Let's say we have two events. We know that event A has occurred, and we're trying to find the probability that event B is occurring. What's the probability of event B? So write the probability of B given A. So we use a vertical line, kind of what you probably used to thinking of as an absolute value symbol. So the probability of B given A. That's how we're going to note a conditional probability. And here's our equation to find it. If we know, if we have events A and B, the probability of A given B will be equal to the probability of A and B divided by the probability of B. So remember, A and B is the same as A intersect B. That's the upside down U. And likewise, let's say you're trying to just look at it the other way around. What's the probability of B given A? The probability of B given A would then just be the probability of B and A divided by the probability of A. So again, the only real difference is that the A and B are switched. It's not that doesn't really change much, but it's something that's helpful to see them both ways, especially when you first start learning this. So you want to make you want to understand this part of it. So on top you have the probability of both events occurring. It doesn't matter. You have A and B, B and A. It's the same thing. They're both going to be equal probabilities on top. But on bottom, we're going to divide by the probability of the given event. See, we're given that event B has occurred here, then we're dividing by event B here. And here we're given that event A has occurred, and we're dividing by event A. Now, to kind of give you like to help you build some intuition, this is something that you can kind of see with the diagram. Sometimes I think that way is hard, but let me just try to pose, a simple example I think most of you will understand easily. So, let's say we have, let's say we're trying to, let's say we have a six-sided die, with the numbers 1, 2, 3, 4, 5, and, 6, fair die. And I ask you, like, what's the probability of rolling a 2? You're like, oh, it's easy, it's obvious, it's just 1 out of 6, because there's 6 numbers, and they all have an equal chance of rolling up. So probability of rolling a 2 is 1 out of 6. And I'm like, okay, well, now if I say, what's the probability of rolling a 2 given that you rolled an even number? The probability of having a 2 given that you rolled an even number. You don't know what that number is, but I told you, hey, you rolled an even number. What's the probability of it being a 2? So think for a second. So I told you that you roll a die, and I'm telling you that it's an even number. What's the probability of it being a 2? Now, if you figure it out 1 out of 3, then you'd be right. Because if it's an even number, that means it's either 2, 4, and 6. See, but so being given some information affected your answer. It gave you a different answer than just finding the probability of 2. So let's see how this relates to this formula. So let's say the rolling a 2 is our event A, and an even number is our event B. The probability of A given B, we'll say that. And here in our formula, it says that we're going to have the probability of A and B on top. But let's think. A and B would just be rolling a 2 and an even number. So the probability of rolling a 2 and an even number. So what's the probability of rolling a 2 and an even number? So rolling a 2 and an even number. Well, it's just gonna be 1/6. It's kind of like a trick question because a 2 is an even number. Whenever you roll a 2, it's gonna be even. So it doesn't really, that second part doesn't matter. It's always gonna be even. 2 is not gonna be odd sometimes or even other times. It's always even. So that top is just equal to 1/6. Then the bottom, we're gonna divide by the probability of B in our formula, remember? And a B is an even number. So we're gonna divide by the probability of getting an even number. So what's the probability of an even number? Well, we have 1, 2, 3 even numbers. Out of the 6, so 3 out of 6, so the probability of rolling an even number is 3 out of 6, or you can say 1/2. So the probability of A given B, or the probability of rolling a 2 given an even number, would be then 1/6 divided by 3/6, which you know by multiplying, by the reciprocal. By the reciprocal, you would get 1/3. So the probability of rolling a 2 and an even number is just 1/3, which is what we got, without having to do a formula. So that's like the simplest way I can give you help you build your intuition, because sometimes this stuff can be confusing when you overthink it. But just understand that the fact that you're being told that an event has happened limits your possible outcomes. Like in this one, you're told that an even number came up, so you don't care about the 1, 3, and 5 anymore. Okay, but as always, it's always good to go through some examples. So let's go through some so we can better understand this stuff. All right, so here we got that we have students at the University of New Harmony. They received 10,000 course grades last semester. This 2A table breaks down the grades by the school of the university that taught the course. We have liberal arts, engineering and physical sciences, health and human services. And it says that college grades tend to be lower in engineering and the physical sciences than the liberal arts and social sciences. So we're going to choose the University of New Harmony course at random, and we're going to consider the two events. That event E is that the grade comes from an EPS course, and L that the grade is lower than a B. So we want to find the probability of L, and we're going to interpret it to find the probability of L. Okay, so here's our table. These are going to be all of the total A grades, Bs, and then below Bs. And across we have, the schools. But we need to it's figure out all the column and row totals, because that's going to make our lives a lot easier if we do it now than later. We add these three down, we get 3392. Add these three down, get 2952. Those 3656. We know the total is going to be 10,000. Add across, we get 6,300. Here you get 1,600. And here you would get 2,100. Okay, so the probability of L, the probability essentially of picking a grade that's lower than a B. That's what L is, the grade is lower than a B. So the grades that are lower than a B are right here. So we just look at the total. So that's just going to be your 3,656 out of 10,000. So 0.3656. The probability of the probability of randomly selecting a grade that's lower than a B. Making a grade lower than a B is 0.3656. Okay. Now, part B, we have find the probability of E given L and the probability of L given E, and then figure out which of these conditional probabilities tells you whether this college's EPS students tend to earn lower grades than the students in the liberal arts and social sciences. Explain. Okay, so let's set this up. The probability of E given L. And let's have the probability of L given E. Okay, so when we're given the formula officially, like initially, we're told that the formula, let me write on my little thinking, like we're told that the probability of A given B is equal to the probability of A and B over the probability of B, and the probability of B given A is equal to the probability of B and A divided by the probability of A. Let's put that right here. And that's an A. Okay, now, when you're first learners, it can be a little confusing, especially, if you're paranoid about using the formula. Just match the correct letters, E and L, A and B. So A and B, remember this is just, the top is the probability of them both occurring. So the probability of E and L divided by the probability of L, because remember they were dividing by the second one. And likewise, we just do the probability of L and E for here. And we divide in this case by the probability of E, because that's what we're given. Move that up a little bit. Okay, so working through this, we're looking at the probability of being in an engineering and physical sciences or physical sciences college and getting a grade lower than the B on top. So we look at what we got over here. How many students in this row have grades lower than B? Because remember, we're told they'd have to be in engineering and their grade has to be lower than a B. So when we're told there has to be in engineering, we automatically know it's going to be in this row. So since we have, there's 800, and I think I said that wrong. They don't have to, so the probability of E and L, this is just that they both occurred. So it's kind of the intersection. So they're in engineering and their grade is lower than a B. So they're in this row and they're in this column. So that would just be that 800, because that 800 is they're in engineering and their grade is below a B. So on top we would have 800 divided by the 10,000, because remember we're not doing a conditional probability on top here. And then we look at the probability of them of getting a grade lower than a B, which we already found over here, which we found to be, we can actually just leave the fraction because it actually makes our math easier. 3656 out of 10,000. Then we take this and then we get basically it's 800 over 3656. The 10,000s cancel each other out. And we get about 0.219, so 800. About 0.219, 0.219, we could say. Okay, here now, the probability of L given E, the top remains the same. Remember, L and E, the same as E and L. The same thing you're saying in, in backwards, I guess. So on top, we have 800 divided by 10,000. But now here we have to find the probability of being in engineering, probability E. The probability of being in engineering, we just take this row's total, which is 1,600, and this will go in our denominator. The probability of being in engineering is 1,600 out of 10,000. And the 10,000s cancel, so we really get 800 out of 1,600, which will then give us, just 1/2 or 0.5. Okay, so now the question is, well, which of these tells you that the students, EPS students, the students that are in engineering and the physical sciences earn lower grades than the students in liberal arts and social sciences? Well, let's think about this. If you look at the initial conditional probability, you want to see which ones have to be in the engineering, because if we're trying to figure out if the engineering students' grades are lower than the other students, then they have to be in engineering. And this is what that's going to be, because we're told that they're going to be in engineering, the probability of L given that they're in engineering. And this value is basically saying that the probability of a student getting a grade lower than a B, that's given that they're in an engineering, is 50%. So for the students that are in engineering, 50% of them get grades lower than a B. So then this one is going to tell you that, yeah, they get lower grades than other students. All right, so here you go. Here's the answer. I've written it all out. So the probability of getting a grade lower than a B given engineering is 0.5. And that tells you that the engineering students, again, get lower grades on average than the other students, because this is higher than the probability of just getting a grade lower than B, which we found to be 0.3656.